Hello friends, welcome back. Hearty welcome to you. Let us look at this problem related to determinants. We have been given a 3 by 3 matrix with the values a plus b plus c minus b minus c, a plus b plus c minus a minus b minus a plus b plus c. We have to show that the determinant is 2 into a plus b into b plus c into c plus a. Now, when we closely observe the whatever the values we have been given, the elements of the matrix, we see that if I do first row added to the second row, I am getting a plus b common. Then similarly, if I add second row to the third row, I am getting b plus c common. So why can't we go ahead and do that? So let's write down R1 is assigned R1 plus R3 and R2 is assigned R2 plus R3. When I do R1 plus R3, A plus B plus C minus B. That means B will cancel, we will get A plus C. Similarly, when we do R2 is assigned R2 plus R3 minus C minus B, we will get minus of B plus C. Like that we can look at every column. So let's go ahead and write down that R1 is assigned R1 plus R3. So A plus B plus C minus B equals to A plus C. Next, minus of C plus A. Next, minus B plus B cancels, again we got A plus C. Let's go to R2 is assigned R2 plus R3. We'll have minus of B plus C, A and A will cancel, you get B plus C. Again A and A will cancel, you get B plus C. Now you can see that from the first row I can take A plus C out, and from the second row I can take B plus C out. Now once we are able to take them common, we are going to get ones and minus ones. And you know, when you add 1 and minus 1, we will get zeros, and zeros is what we are looking for. So let's go ahead and take A plus C and B plus C common. We are left out with 1 minus 1 1, minus 1 1 1. Then the last row is minus B minus A plus B plus C. Now we want to get zeros, so let's go ahead again and do R1 is assigned R1 plus R2, so that we can see two zeros there. Then easily we can find out the determinant. Then we can expand it on the first row. So let's do that. R1 is assigned R1 plus R2. Then I will have A plus C, B plus C out. Then we have 1 minus 1, that is 0, minus 1 plus 1, that is also 0, and 1 plus 1, which is equals to 2. So we'll have 0 0 2. And the second row will be as it is, minus 1 1 1, and the third row will remain the same like earlier, minus B minus A plus B plus C. Now let us expand by first row to get the determinant. When I expand by first row, first two elements of the first row are zeros, so only thing I have to worry about is the first row last element, that is 1 3. So first row third column. Let's go ahead and try to understand what is the 2 by 2 matrix, how it looks like. 2 into A plus C into B plus C. Take out that row and column. What is the 2 by 2 matrix left out? Minus 1 1 minus B minus A. And we know that ABCD is a 2 by 2 matrix, then its determinant is given by AD minus BC. Let's apply that formula. We will have 2 into A plus B into B plus C into C plus A, because that 2 by 2 matrix is determinant is nothing but A plus B. So finally, everything put together, we get 2 into A plus B into B plus C into C plus A. So to summarize what we have done, we did transformation. We did R1 is assigned R1 plus R3 using the properties of determinants. R2 is assigned R2 plus R3. After that, we took A plus C, B plus C out. Then whatever we got, then we expanded by the first row to get the determinant, and we understood that the determinant is 2 into A plus B into B plus C into C plus A.